Hello, everyone. Thank you for the introduction. Might be a bit different talk and maybe a bit different speaker than what you're used to, but hopefully this will be interesting or at least entertaining. So I want to address the question whether tubes might be the future of transport, whether there's any room for tubes in transport in the future. And to do this, I want to take a step back first. And immediately we learned that tubes are not all that new to transportation. In fact, in the middle 19th century and early in the 19th century, there was a number of systems that tried to use tubes for transportation. Couple of them existed in the UK. This particular one on the left-hand side shows a system in New York. They used the tubes and created a difference in pressure in front and behind the vehicle to push it forward. So those were pneumatic systems, something similar to what we saw in shops a few years ago now. None of those systems were too successful. Fast forward a couple decades, and in the early 20th century, a gentleman called Robert Goddard, a rocket engineer and a physicist, proposed that the tubes could actually be used for something different. They could be used to provide a low-pressure environment inside the tubes, not to push the vehicles forwards, but actually to reduce the air drag actually acting on the vehicles to allow them to travel at very high speeds. This was probably inspired, we can only presume, by his work with rockets and the fact that there's nothing in the air in the way of rockets when they are in space. They can just go very, very quickly. And now this brings us to 2013 when Elon Musk, another rocketman, proposed something called Hyperloop. And that's why everyone is talking about this, because Elon threw his weight behind the concept. So it's a transportation system, so by definition you need to start with a vehicle that can carry either passengers or cargo. The vehicle then sits on a magnetic guideway. Why do we not use wheels? Wheels by design do not work at very high speeds. The forces acting on them would just be excessive. The vehicle then is propelled forward by linear electric motors with the stator mounted to the tube and the rotor mounted to the vehicle. And all of this is enclosed in a tube to allow us to do two things. The primary, we take the air out of the tube, reduce the air pressure, and effectively minimize the aerodynamic drag. The air pressure is about 100 pascals. That's something that we think should work right now. And the second thing, we actually separate the transportation system from the external environment. So it's not uncommon for transportation systems to have any clashes with pedestrians primarily. In fact, on my journey today, unfortunately, there was a tragic accident on the East Coast Main Line. So this tube closes this transportation system and makes it safe both for the public and makes it work much better in changing environmental circumstances. And Hyperloop might sound very fancy, but in fact, it's composed of a number of well-understood technologies. So the structure of the vehicle can, for example, be taken from the aerospace industry. It's very similar to what planes use. Civil infrastructure is very similar to high-speed rail, and onboard batteries or autonomous control systems are currently being mastered by the automotive industry. Magnetism and vacuum are not that new for us either. So where does Hyperloop fit in? Why would we even try to do something like this? So this graph plots speed versus specific tractive force, or in other words, the power needed to move a unit of mass at certain speed. And we can see that as the speed increases, so does the power and effectively energy consumption of a transportation system. And this straight line going across the graph, that's state-of-the-art, it's Gabriele Karman line, state-of-the-art of transportation in 1950s. Clearly, we have moved towards the bottom right-hand corner, which is good, there's progress, but still there is this incline, and as speed increases, the energy consumption increases as well. So why is Hyperloop the opportunity here? It takes a different approach to tackling the issue of aerodynamic drag, and it allows us to play with completely new variables. And here I want to introduce you to an unusual group tackling this challenge. It's HYPED, the University of Edinburgh Hyperloop team. Here pictured with our first prototype vehicle. In fact, the UK first Hyperloop prototype vehicle in SpaceX at SpaceX headquarters in California during a student competition. We are a group of 80, 100 students working on this on top of our degrees. About 20, 30 of us actually do it on full-time hours on top of our degrees. And those are the people who are pushing the boundaries. Loads of them are very inspired by what's been happening, and they are looking towards the future, what can come up 20, 30, 40 years down the line. We're currently building our second prototype. The first one was called Poddy Max Podface. This one is called Poddy the Second. It will be much more functional than the initial iteration. It actually packs twice as much power as Nissan Leaf. It will have some life support systems, and we're taking it to California for testing this summer again. So again, where's the whole inspiration coming from? Again, want to take a step back and look at how far we could travel from central London throughout history within just 1 hour. So back in the 18th century, on a stagecoach, it would be about 8 to 9 miles, not too far. When we move on to early railways, this moved on to maybe 30, 40 miles. Modern transportation systems are much better. They take us to, say, Cambridge in under an hour, a journey that on a stagecoach used to take about 5 to 7 hours. Once we have high-speed rail, we will be able to reach Birmingham in under an hour. Big improvements. But with Hyperloop, we think that we should be able to reach all the way up to the Scottish Central Belt within an hour. And the benefits of this could be huge. If you were to build a route linking, it's just an imagination, I'm not trying to tackle high-speed 2 here. If you were to connect over 50% of the UK population with those 12 stations here, the benefits could be huge. Rebalancing growth, rebalancing all of the inequalities, addressing housing issues, or maybe replacing short-haul flights, which, as we know, are not as efficient as they could be. Or maybe we wouldn't have to build the third runway for Heathrow at Heathrow, but 50 miles away, and connect it with Hyperloop on a 10-minute journey. And those benefits have been noticed around the world. It's not just us talking about it here. There's loads of locations working on the concept, and people are not just talking. In fact, two test tracks already exist in the US. Third test track is under construction in France, right at this point. Well, today I'm very happy to say that we are currently forming the UK's first Hyperloop-oriented company over in Edinburgh. And one of our focuses will be working with the industry to leverage their existing expertise and how this could be applied to Hyperloop to make the technology both feasible and viable. So coming back to the original question, are tubes the future of high-speed ground transportation? If we really want to go fast and reasonably efficiently, then yes, it's very likely that tubes might help us with this. And I just want to finish off with something that keeps us up at night, because we really do think that we can get very far if we really stay focused and motivated. Well, we are convinced that the future is bright. Thank you very much.